GCP components and comparison to other clouds, software infrastructure and platform engineering categories, observability, networking, security, what is open source, what is CNCF, brief explanation on each category and tools examples in each category. Now, I am very delightful to hand over this first day session to Mr. Kedarnath Krambi. I welcome you, sir, and you can start the workshop now. Thank you,
Yeah,
sir.
thank you, ma'am. So, yeah, we'll be starting the session on cloud, IAC, and open source software. So, in cloud, we'll be looking at why cloud is needed. I mean, what exactly is cloud? Does it mean? What does it mean? What kind of services does any cloud provider provide? Okay, and along with that, we will understand what IAC is. We'll look at several tools that are popular in IAC. Okay, and in the last topic for this 5-day series, we'll be looking at open source software, majorly CNCF. I'll tell you what CNCF is and how and what are the technologies in CNCF. What is a open source community basically, and how you can get involved and build your profile by contributing to all this open source software, right? So let's get started. So initially, when people used to run their products on physical servers, they were using monolithic applications. We saw these differences in the day 3 session, right? Monolithic versus microservices. So they were using monolithic architecture, and these applications used to be run on physical servers. So people used to buy physical servers. They used to have a server room, and place these servers and do all the wiring. There used to be a network engineer who does all this wiring and configuration setups and all, right? So if the application needed more resources, like application is growing and the people, end users of the application are growing, and they want to add more resources into this, they had to place an order. We Like there are some, like how you buy a laptop in these days, right? So you have to buy a server there. You have to place an order. They would prepare and configure that new server, and that order used to be delivered in 5 to 6 days at a faster level. That's a premium delivery kind of thing. Okay, so if you want to scale your application, it takes a minimum of 5 to 6 days, and there is also, after this server comes in, that network engineer needs again time to configure that, do all the networking with the existing servers, and prepare that cluster, right? They have to run several tests before actually running the application and distributing traffic to that particular server as well. So it would take, let's say, almost 15 days just to spin up a new server. And once you buy this server, um, you have already paid for it. You are paying upfront for these resources, and if you are not utilizing them, then it's a wastage of investment. uh, so let's say you have scaled down your application and you have moved something else, then that investment is not, when it's not used, it's a wastage. So yeah, these are the disadvantages that come with this. There is no option to scale down. It takes weeks to scale up. It need to maintain a small size DC. Yeah. So now you have a server room in your office, and you are maintaining all these servers. You have to make sure that the power is on all the time. That infrastructure needs to be maintained. The cooling systems, everything needs to be maintained, and all that is again cost money for us. So it's hard for startups to have that kind of money to spend on separate team, spend extra time just to spin up a single server, maintain all these infrastructure. It used to be hard for startups to come up. So it needs several teams with different expertise. As I said, you need a network engineer, you need infrastructure engineer, physical infrastructure engineer. All those kind of people with different expertise are needed. So inefficient usage of resources, of course, because let's say your application is having demand for some time, seasonal demand, or some demand in particular time of the day, then all the rest of the time, it's basically unused, and you have already paid for it. So that's also there. But there are also some advantages, like data security and confidentiality. So since you are maintaining your own servers and everything exists within your office, you know what's happening inside your servers. Data is secure as long as you maintain a secure office premises, and confidentiality. Your application data is not going anywhere outside your office. It's staying inside your server room, and there is full control and visibility as you are the one who is doing that. Your employees are the ones who are doing the configurations and all, and you know what exactly is happening. If something goes wrong, it's your responsibility, but no, you are not you are sure that your data is not being leaked somewhere, or someone else can see your data or something like that. So that those are also the advantages that are present. So what exactly is cloud computing? uh, what we talked about is the earlier scenario when cloud was not there. So this is cloud computing. uh, it's basically a delivery of computing services on demand over the internet across the world. Like the computing services in the sense, any service that provides computing power like CPU, all these things to run your applications. They can be servers, they can be storage, like databases, right? They can be networking resources, software, analytics and intelligence software, whatever it is. So all these come under computing services. It allows users to access these resources on demand. Like when you uh, click on some button, you'll get the resources. Like when there is a demand, you request for it and it will be delivered to you within few minutes or seconds. Okay. So, and you typically pay for only what you use here rather than owning and maintaining the physical structure. You are just paying for what you use, how much time you used and what amount of resources you use. You just pay for that. So let's say there is a user, and there are data centers located across the globe. So cloud computing in the sense, it's not stored in cloud, right? There are data centers somewhere, and you are basically using a part of those resources through the internet cables that are spread across the globe. So you place an order, like you need a specific so and so configuration VM, and it will be delivered in minutes to your system, or you can just access it using a desktop or a browser. You don't need all the data center setup, network engineers, all that. Okay, so it's increased the advantages of the cloud computing. It's increased efficiency. What does it mean, increased efficiency? It's simplified IT management, faster application development and deployment. So you don't have to wait weeks and months for just for adding one or two new servers. uh, and you don't need a team to forecast, okay, in this following few days we'll have a new we'll have increased load to our application, so that's why we have to order before itself and estimate all that things. So there is accessibility. The services and data can be used from anywhere with an internet connection. You can sit in a cave shop, coffee shop, and then work on your laptop, demand resources, and run your application, right? So innovation, since faster development and deployment and lower cost, propel these startups to come up faster, right? Since it has become easy and you don't need that much budget to spin up these servers. You can just run an application, and startups, it makes easy for anyone to start a startup, right? So cost savings, scalability and flexibility. You can scalability in the sense, increasing resources or decreasing resources. Flexibility is doing it whenever you want. So just to understand how, so these data centers are located across the globe, right? How are you sitting in India somewhere in Hyderabad or Vijayawada or wherever it is? How can you access all these resources, right? So all this cabling is done. Physical cables are laid out across the globe. Uh, this is Google's network, like GCP cloud. Google Cloud Platform is there, right? It's a cloud provider platform, and you have all these connections wired here. Uh, the green ones are the ones which are investments, like submarine cables, and blue ones are the ones which are already laid. Okay, so let's see what services are there, like different types of cloud computing. So these are important to understand. You need to know what IaaS is, PaaS is, and SaaS is. And several product-based companies also come up with these terms. So whenever you are applying for a company, you will see something like this is a PaaS company. But if you don't know what is PaaS, then you will not be able to understand, right? So it's important to understand these terms. So please concentrate here. Infrastructure as a service means it's providing basic computing resources like virtual machines, storage, and networks, right? So infrastructure, you are using that or demanding that infrastructure as a service. Uh, let's say you are creating a EC2 instance in AWS. That means you are requesting a virtual VM from AWS. That is infrastructure as a service. Okay, that's basic resources like infrastructure. And platform as a service, what it means is it offers basically, whoever is selling that service, they offer a platform for developing, running, and managing applications. uh, they will take care of infrastructure and tools, and they create a platform for you, like Google App Engine is there. You just focus on the code, and your focus is on the application, not on the infrastructure where it's going to run. Okay, because all that headache is taken by the provider, whoever is providing that platform, right? So they will take care of infrastructure. They will make sure we have agreements, right? So 99.999% availability, that's their headache. They have to meet that agreement. Okay, and you are just deploying your application on that platform. So that is platform as a service. And software as a service, these are basically things which we use all the time. Even this Google Meet, Gmail, uh, basic things which basic softwares which we use, these are software as a service. You don't care about where Gmail is running. You don't care about how Gmail is running. You are just using the service, that product. You are just signing up and using it. So that is software as a service. So what are the challenges in cloud computing? All right. So since we are, let's say we have created a S3 bucket or something like that, we are storing our personal data inside that. But how sure are you that my data is confidential and my personal data is not going anywhere? It's not being leaked anywhere. So that is one challenge, because you don't know where it's being stored and how it's being stored. The public cloud depends on a network of a third party owned, shared, and remote servers, right? So let's say you are creating a storage in AWS. AWS might have some agreements with other third party companies. It's not all owned by AWS only, right? So they have some agreements, but who will know, who will honor, or who will break those agreements, right? So data confidentiality is a matter of trust. Okay. um, Businesses concerned about securing business secrets, customer data, compliance information find this particular challenge very painful. Even now, uh, in the previous projects, like where I worked in NPCI, like National Payments Corporation of India, it deals with UPI and all that, fast tags and all. So they never use the cloud providers like GCP or AWS. They set up their own data centers because that data is sensitive and they don't trust these cloud providers. Okay, so data security, this is also similar to confidentiality. If security is there, then confidentiality will also be there. Obviously, if security is not there, someone might just easily hack into it and sell all the data. So cloud computing over a cloud service provider's infrastructure involves transferring data remotely and accessing it from any computer or device. You are storing some data and you are accessing that through your device, right? That means data is flowing through the internet from somewhere around the globe. You are creating a storage in US East 1, some region, and you are accessing it from India. Then how is that data coming to you? It's flowing through the internet, right? So it's going through public internet. So data security is also a uh, concern there. And infrastructure control. Uh, to optimize the performance of their cloud services, some companies prefer more control over the backend. However, there is a varying limitation there depending on the cloud service provider. Some providers, I mean cloud service providers, CSPs, they give you more control on the infrastructure, but some do not. Vendor lock-in. Let's say you created all your application, you had this particular team, they have worked hard and you have burned a lot of money and created your entire setup on a XYZ cloud service provider. Okay, now that service provider, what they do, they revise their terms and conditions. They'll say they'll increase the prices randomly, or they can add whatever conditions they want because it's their cloud service, right? So now you are stuck in that XYZ. You have to pay all that money, extra money. You have no way of going outside and using other cloud service because they have set up the cloud in such a way that it's completely tight coupled and dependent on that cloud only. So vendor lock-in, such things are also a concern for us. uh, any cloud needs to be in such a way that you are not locked in. You are free to move into different clouds if your business demands for it. So to work around these challenges, many companies are now embracing multi-cloud strategy. So it's not just, okay, I'll deploy my application in only Google Cloud or in only AWS. They are not doing that. So they are running half application in GCP, some other application products in AWS. So they are leveraging advantages of multiple cloud services. So let's say you have computing power, application that needs computing power, AWS can be used for it. Uh, your application needs some analytics, right? Some processing of the data and all. Google's GCP is known for data processing and all. So their products are very good at that. Then you will use the analytics product, you will run the analytics product in GCP. So these kind of multi-cloud strategies are being used. So your application can be run in multiple clouds. This will avoid vendor lock-in. There is a balance of performance and availability and cost. So since cloud providers are like, okay, these people are running multi-cloud. So if I add too much increment in my service cost, like let's say my EC2, if I bump the cost, then they might not use my service, right? So they are also in control here. It also improves resilience, and it also increases the flexibility. But you will also need to have resources who are good at multiple cloud technologies, not just one or two, right? So a multi-cloud strategy means running your workloads across two or more cloud services, cloud service providers. It's become a popular approach for companies that want flexibility, reduce risk, and avoid vendor lock-in. Instead of relying on one provider, businesses spread their services. So next we can go with this. So in cloud service world, the three chains, as you know, are AWS, Azure, and GCP. First is AWS, second is Azure, followed by GCP. AWS has a 29% market share across the world. Azure has 22%, GCP has 12%. So there are a lot of cloud service providers that also came up. You might have heard of it, you might not have heard of it, but these are some of the cloud service providers which I listed here. And even I didn't hear of it until I prepared this presentation. So yeah, there are 21 plus CSPs as of now, I think. And Alibaba Cloud, it has 5%. This is popular in Asia. IBM Cloud has 4% market share, and these are also other with minor shares across the global market. Right. So there are so many cloud providers. So which one should I use? Even among the three chains, which one should I use? Right. So not all providers are built the same. Right. Here are the key things which you might have to look at before choosing a cloud provider when you run the application. So one is cost. Uh, there should be billing transparency. For example, let's say GCP is there. They have a GCP cost calculator website. Okay, you can just go there. You can specify the resources you need, and it will give you a calculated cost, like which service is costing how much, and what is your total cost coming to. So that kind of transparency is there. Some cloud providers provide discount programs, like in EC2 or something like that. If you use dedicated resources, let's say I'll use this EC2 instance for, let's say, 3 years. I'll not stop it or I'll not terminate it. I'll definitely use this for 3 years. Then that guy will give you a discount. Okay, so since you are using my service for 3 years, I'll give you a discount. So that kind of discount programs are there. Cost predictability, uh, like that calculator is can be used as an example here again. So you can predict the cost, you can plan for it, and you can run your application. So that kind of features needs to be there in the cloud. And ease of use, right? So how good is their UI or APIs? Is it easy to use, or you have to like spend a lot of time and effort just to spin up something? All these have to be taken care of. How intuitive is their dashboard or API? Okay, so all that. And support, when you are stuck with something, or when something is deleted accidentally, then who do you reach out to? Does that cloud provider has a proper support team, or do I have to make a loss there? So if there is a support team, are they working 24 by 7? Is it like a AI agent that's answering my calls, or is it a resource person actually dedicated resources for my team or for my company that's answering these calls and taking my care of my support tickets? So all these needs to be thought about as well. So deployment flexibility, uh, I I need to have some resources public, I need to have some resources private. No, it needs to support multi-cloud. um, Resources or application running in my cloud, like in XYZ cloud, need to talk, be able to talk with services running in ABC cloud as well. So that kind of support, is it there or is it not? So performance and scalability. So does the cloud provider has services that do all this, that provide all these features like growing workloads? Are they having their services up most of the time, like 99.999% availability? Are they just saying that, or is it actually in practice? Okay, so that all these things also need to be focused on. Security and compliance, this is one of the most important things. uh, when you store your data or when you run your application code inside that, nobody else needs to be looking at that, right? Or else your entire product is compromised. Someone can build a replica of your product and do something. uh, and there are some terms in Canada, US and all, that protect user data that are used by these applications, right? So if there is a citizenship data, uh, let's say there is a product like a CIBIL score, that will deal with CIBIL score or financial data which is sensitive. Okay, all these data are protected by these HIPAA and GDPR boards, right? So they set strict rules on how data is controlled and managed. Uh, are these services provided by the cloud up to these standards? If they are secure or compliant, that's one thing. And integrations. So this is basically the same as multi-cloud thing. Is it compatible with your existing tools? Let's say you want to use Kubernetes, right? In earlier times, Kubernetes just came up into 2014 or something. So let's say you wanted to deploy your application using Kubernetes in 2016. Does it support that? Or I mean, what I mean is, does the cloud service provider has services with latest technologies that you want to make use of? So that's also a point that needs to be considered. And location. So we just saw a map right across the globe. Uh, I stay somewhere near Russia, let's say. Are any data centers there? How long will it take for the data from the data center to come to my location? Is there any latency that's added? And are there services in that particular data center location that have compliance related protocols? So that is also a concern. Now there are core services, right? Any cloud, if you want to deploy an application, you have to make use of these core services. You need a compute resource, be it a storage, be it a VM or a serverless VM like Lambda function, microservices like Docker or Kubernetes, all you need to have some compute power to run your application, right? So that's a core service. Storage is also there. You need to store some data. Application, what it does, it will process some data. That data needs to be stored somewhere. It can be a SQL database, PostgreSQL database. It can be a S3 bucket, like any type of storage, right? All these services or application, when you're deploying in any cloud, they need to talk with public internet or within the cloud, within the from service to service. uh, how do they communicate? They communicate through some network, right? So there are VPCs, load balancers, CDNs. Okay, these needs to be there. And databases as similar to storage, different types: relational databases, non-relational databases, all that, like Firestore, NoSQL, whatever. And security, of course, when you are deploying an application, you are basically running a company. You have multiple employees. You need to control the accesses. Like, you shouldn't give delete access to every employee, right? So if they delete your application, then you are gone. So IAM and security services, monitoring tools like who is accessing what, all these things are also a core service. So let's say AWS is there. In AWS, there are hundreds of services, right? If you want to master AWS, then you have to, like, it's not like you have to master all the services, like what they do, how it works internally, what is the uptime agreement for them. All that you don't have to take care of. If you want to get started with cloud, any cloud, um, and get you know uh, better at it, these core services are mandatory, like any compute, storage, networking, databases, and security. So if you learn these, then cloud, you can say that you are good at a good level in cloud computing. So let's look at each service one by one. So compute. um, So compute services, basically what they refer is, they refer to the provision of virtualized power. You are running a EC2 instance or compute engine in GCP, for example. You can customize them. You can have 3 GB RAM, 4 GB RAM, or you can have 32 GB RAM, 64 GB RAM. Um, so you have different specifications, different operating systems, and even if you have multiple, like hundreds of instances, you can set up something like mixed managed instance groups or auto scaling groups in AWS. Basically, they both are the same with different terminologies. Okay. What it does is, you can write a template, basic template, like my compute instance need to have 16 GB RAM. It needs to have a Linux operating system, like Ubuntu operating system, with so and so specifications. You need to write that, create a template, and you can spin multiple number of instances using the same template, instead of specifying the config every time you create an instance. So all that kind of things are there in VM. um, so serverless is also there. You might have heard of Lambda in AWS. There is a similar service called Cloud Run or Cloud Functions in GCP. What it does is, it's basically a platform as a service. You don't have to manage the infrastructure, like the instance patching, server maintenance, vulnerability checks of that particular VM. What OS version is it running? Are there any vulnerabilities in that OS version? You don't have to take care of all that. Cloud provider will handle that infrastructure. They will maintain it up to date. They will handle patching without bringing your application down. Okay, you just have to focus on creating the application and running that application. uh, and you have to pay for how much resources that application is using, like how many requests did it process, how many CPU power, how much CPU power is it using, all that. So microservices again, which we discussed in previous two sessions. You can run containers, you can run Kubernetes also, clusters also in cloud providers. So next service is storage. storage can be of different types, basically. Object storage, file storage, like block storage. Uh, in object storage, you are basically storing anything like in the form of objects like videos, uh, YAML files, docs, anything. Okay, in the form of objects, if you want to store it, this is the one. And in AWS, it's S3, and GCP, it's storage bucket. I'm just taking these two, AWS S3, AWS and GCP, because I'm familiar with them. And there is a file storage. Uh, this is basically a folder structure service, that can be shared among multiple people for collaborative work, and applications that require a shared file system. So NAS is the popular one in that. There is also block storage. This is basically our uh, storage hard disks, which is used by our systems or virtual VMs, anything like that. They are called elastic block storage in AWS and persistent disk in GCP. So data is basically stored in blocks, and each block is having a unique address. This allows for high performance and is often used for databases applications that require fast access to the data. So I'm not adding databases here because we listed database as a separate service instead of storage service. Networking networking is very important if you want to become a cloud architect or something, someone working with cloud, because you need to know how these services communicate with each other, and your application needs to be deployed in a secure environment, right? So you will need to understand what type of networking you can configure and what services a cloud is providing to control your network. So one is VPC and subnets. VPC is nothing but virtual private clouds. It's called VPC only in both AWS and GCP. Okay, so but though it's called the same, they differ pretty much in terms of okay, VPC in AWS can be regional, but VPC in GCP is a global resource. You can have one VPC that is across the globe, and you can create subnets inside that VPC that are regional. But in AWS, it's not like that. You can create regional VPCs as well. So virtual private clouds are basically a logically isolated section of cloud providers network where you can launch your cloud resources. What does it mean? Let's say your cloud provider has a network and you are taking a piece of it and you want it to be isolated so that other services running in that cloud services network are not interfering with your applications, your services. So VPC is basically an isolated section of that cloud services network. Within that VPC, again, there are you can create subnets, as I said, that are again a small sections that are isolated and have a range of IP addresses inside that VPC's IP address range. If your IP address of VPC uh, allows for 1,000 IP addresses, let's say, each subnet can have 10, and then you can spin up 10 subnets. If your VPC has reached any limits, like you have exhausted all the IP addresses, then you can ask the cloud provider for extension. They will extend the limits of your account, and then you can start using them. But then again, this is something you have to check before itself. Before is there some feature like that? Is there a possibility to extend my IP addresses range? Uh, is it possible? Cloud provider can just say no, you created this VPC only for this range. Then you have to create a new VPC again, and you have to migrate all your application from current one to this one. But that's a lot of process, right? And effort, time, money, resources, everything is wasted there. So that's why I mentioned earlier, like all the features that you have to take into consideration before selecting a cloud service provider. Yeah, subnets can again be public or private. What it means is public subnet. It's basically public and visible to the internet. Uh, Not internet, inside the even inside the cloud service provider, and it can have a route to public internet. So private in the sense, it's a closed off space. Unless you provide a route for it, you can't access the resources inside the private subnet. And there is something called availability zones again, and these subnets can be placed across availability zones. So you shouldn't get confused between subnets and availability zones, because availability zones are physical things. They are locations. You have a data center location, which can be called in a region. Let's say in Andhra Pradesh, you have let's say 2 data centers. Those can be called as Andhra Pradesh is the region, and these can be called as the availability zones. These 2 data centers, right? But subnets are basically a network, isolated network sections which have its own IP addresses. They can be public or private. That's a bit about VPCs and subnets. Now let's come to DNS and load balancers, right? So DNS is basically domain name service. Uh, what happens is it translates. Uh, we are giving some URL, right, in the browser, like google.com. It's a human readable thing. They DNS is responsible for translating these domain names that are in human readable format into IP addresses that computers understand, right? So cloud-based DNS services offer scalable, highly available managed solutions for this process. These services are basically crucial for ensuring reliable communication and connectivity within cloud environments. You see, across the internet there are several public DNS servers, and even you can have your own private DNS server. So yesterday when we saw in Kubernetes, there was, when we spinned up a Kubernetes cluster in kind, using kind, and when we saw what namespaces are there, there was kube system, right? Inside that kube system namespace, all the control plane components were there, along with this core DNS. What is that core DNS? It's a DNS service. That's a private DNS service that is exclusive to that Kubernetes cluster. Whatever, let's say you wanted to reach some pod, right, with some pod name. How will that pod name, which is like human readable format, converted into pod IP address? That's because of this core DNS that's running inside the Kubernetes cluster. So similarly, in cloud also you can have your own DNS service that handles the translation, that helps in communication between your services within the cloud, within your cloud account, right? So these, so as that said, these services are crucial for ensuring reliable communication and connectivity within the cloud environments. So why do you need to go for cloud based DNS? You can spin up your own DNS service, right? So why cloud based DNS means they provide several things like scalability, availability. They are designed to handle a large number of requests and maintain high availability. They ensuring that websites and applications remain accessible even during peak traffic. So they have global infrastructure. uh, when you spin up a DNS, it might be in one location, but this cloud providers DNS, they might be there across the globe, right? So they also get integrated with other cloud resources pretty easily because it's provided by the same service, cloud service provider. So some DNS services offer features like load balancing as well, based on health checks of the end resource. If you know Route 53 in AWS, it's also a DNS service that provides this feature, load balancing. Uh, when it load balances to different virtual VMs in the backend, it will check the health. It will do health checks from time to time, and it knows which VM is up and running, which is in a healthy state, right? So it stops sending traffic to any VM that is considered as unhealthy, so that any traffic that is processed, it's going to a healthy VM. And not only that, Route 53 offers several things like weight based routing, location based routing. Let's say your traffic is coming from so and so location, then it's easy and faster to process that traffic from services in that same compute services from the same location. So it does that as well. So there are several load balancing features that's provided by DNS. It's route 53 in AWS. In cloud DNS, it's in GCP, it's called cloud DNS. So firewalls and ACLs. So what are firewalls and ACLs? ACLs are basically access control lists. So they are essential in network security. Um, so firewalls, they do? Um, they act as a barrier between different networks. So even within your cloud network, you might have different sub networks, right? So between these networks also communication when it happens, you can put a firewall in between them that blocks certain type of traffic, so that if one sub network is compromised by some hackers, and there is a firewall between multiple subnets, it will become harder to spread the damage to multiple things. You are basically isolating your damage. ACLs, on the other hand, they are a set of rules that control access to specific network resources or devices within a network. So firewalls monitor and filter network traffic, acting as a gatekeeper to prevent unauthorized access and malicious attacks. Okay, what is the scope of firewall? They operate at network or application layer in the OSI layer. They provide comprehensive security by examining and controlling traffic flow. How do they know which traffic packets or network packets are malicious or unauthorized? They do packet filtering. So they examine packet headers. So if you know, the data passes through the network in the form of data packets. Each packet has its own header that has some metadata about the packet payload, right? So packet filtering is done at firewall. Basically, firewall examines that packet headers to allow or deny traffic based on the rules. You will configure some firewall rules. Based on those rules, it will filter that. And there is a stateful inspection. They track network connections to make more intelligent filtering decisions. Uh, okay, that is about firewall. And ACLs, they are used to define permissions from accessing specific resources such as files, folders, or network devices. Uh, while firewalls operate at network or application layer, access control lists, they are more granular level control. They control access to individual resources within a network. So both are rule based, and ACLs, they are also source and destination based. So ACLs can filter traffic based on source and destination IP addresses, ports, and other criteria as well. So an ACL can just be used to allow any members of specific team to access a shared folder. Let's come to databases now. So databases can also be called as DBAS, database as a service, basically. Uh, so what happens here is you um, request for a database and it's on-demand access. So database as a service offers an on-demand access to a database hosted and managed by the third party or cloud service provider, right? This eliminates the need for organizations to handle the hardware procurement, software installation, ongoing maintenance, patching, and all these things, allowing them to focus on only the application development and data analysis. So it's a service where a provider delivers database to you. It can be a relational database, non-relational database. There are some things like Firestore, all these things as well come under this database section. So it's a managed service. Providers handle database administration tasks like provisioning, patching, backups, scaling that database, all that things. Cost savings are there. Like any cloud service, you can save costs here as well, because you avoid capital expenditure on hardware, and reduce operational costs. So there is scalability as well. Since it's a cloud service, it needs to be scalable. It needs to be highly available. There is reduced complexity, because you are not the one managing the database. And accessibility. Users can access this database from anywhere using that internet connection and a cloud account. So there are different types of databases. As I said, it can be relational database, NoSQL database, data warehouses, and HTAP systems as well. So relational database is basically structured data stored in tables with predefined relationships like foreign keys, all that. And examples are like PostgreSQL, MySQL. NoSQL databases, they are similar to unstructured or semi-structured data. MongoDB is a famous, MongoDB is the one of the popular NoSQL databases. And another example can be Cassandra. Okay, cloud data warehouses are there. They are optimal for analytical workloads. You basically they do pull up this analytics data and put up some graphs on that, right? So for that, and large data sets are there, so like petabytes and all that. So BigQuery from Google, Snowflake is a separate company that excels in these data warehouses. Amazon Redshift is there, like from AWS. Okay, these are the examples for cloud data warehouses. Hybrid transactional analytical processing systems are there. So they basically combine both transactional and analytical capabilities. They are like hybrid, as its name suggests. And an example can be Google's Alloy DB. Now let's go to security. Even firewalls and ACLs come under security, but they are more into networks, so that's why it was placed there. So security, when we see, we have several ways we can ensure security in a cloud, right? One is IAM. IAM is basically identity access management. It gives us to access, fine-grained access control on who can access a particular resource. It also provides visibility for centrally managing enterprise and cloud resources. So multi-factor authentication, role-based access, those are the examples like IAM practices. You can write policies and enforce them on several resources. Like who can log in into your cloud, who can access a particular EC2 instance with particular labels, maybe. So that can also be controlled. And security, as I said, can be enforced at multiple levels, right? So at what levels can it be enforced? All this is mentioned there. So data security, network security, monitoring and logging, compliance and governance, no, vulnerability management, incidents response, business continuity, and disaster recovery. So data security is basically focuses on protecting data both in transit and at rest. So when you store the data, it needs to be encrypted. It needs to be secure even when it is moving through the internet, right? In transit, it's secured using HTTPS, right? For example, and at rest, you can just use some KMS or something to encrypt that data. There is data loss prevention also in data security that helps prevent sensitive data from leaving the cloud environment. In network security, we just saw VPNs, right? Access controls, lists, and firewalls. So those are all network security only. So security monitoring and logging, you can monitor cloud resources for suspicious activity, and there is a audit logging as well. So who is doing what, like using admin credentials for what, all these come under audit logging. So security information and event management like SIEM systems are there. So they can aggregate and analyze security logs from various sources. This basically helps detect and respond security threats in real time. And there is compliance and governance. Compliance, as I said, like HIPAA and GDPR, they they follow these legal and regulatory requirements for data protection and privacy. And let's say you logged into some application and they are using your login information like phone number, email, and they are selling it to somewhere, it's not acceptable, right? So there needs to be some sort of compliance and governance that and that these companies needs to follow. And cloud service providers who manage and store these data, they need to be compliant as well. So some examples like GDPR, HIPAA, ISO 27001 is there, I think. Yeah, even that is also there. So cloud security posture management, CSPM, that is a tool that helps organizations continuously monitor, their cloud environments for compliance violations. All these tools also need to be used by a company, and cloud service provider can provide these tools as well as a service. So vulnerability management, regularly assessing cloud infrastructure and applications for vulnerabilities is essential. Of course, it because that's a security concern. Vulnerability scanning and penetration testing help identify any loopholes or weaknesses. Remediation efforts needs to be done, like patching and configuration changes to address these vulnerabilities. So we have incident response and planning. There is a well-defined incident response plan is crucial for managing, minimizing that incidents, right? So that is also provided as a service. Disaster recovery is basically business continuity and disaster recovery. Let's say if some region is affected by some natural disasters like floods or earthquakes, you should make sure that you have a backup plan. That is basically disaster recovery. When you design your application in a cloud architecture, you have to ensure that you have to take into that account. Of course, disaster recovery comes with its own cost, like in terms of cloud services usage and the team effort and all. But it provides a backup plan for you in case of unexpected natural disasters. So we have almost hit 1 hour mark. So we'll just take a few minutes break.
Hello, participants. Yeah, just we're having still 1 more hour. So if you have any doubts, you can raise the doubts. Okay. So as we'll continue again. So if you have any doubts, please notice that, and then you can ask also. Okay.
let's look at this sample architecture. This is a simple application that's running in AWS. Okay. This is a sample architecture that's designed for this application. We have a app server and we have a web server. Web server is running in an ASG group, and this is a app tier. So there is a load balancer in front of these. So that's distributing the load, and you're you have a route 53 hosted zone that will do the DNS work for us. So all the static content is basically stored in S3 bucket, and there is a cloud front that will serve the static data and decrease the latency. This app is basically using a database like Amazon RDS, and there is a backup instance also that's on standby. There are two AZ groups. Basically, the data is only backed up here. Just in case if something goes wrong with the availability zone 1, the zone 2 RDS can kick in, right? So there is a cache as well that will help reduce the application hits on this database. If the same data is queried multiple times, obviously what cache means, right? It will basically cache these results, store these results. Instead of hitting the database again, application first checks with the cache if the results are there. If it's there, it will be sending that data back. So you are avoiding, reducing the number of hits on the database, which is again a additional cost. So even for this small application, you need to have several things, right? You need to have route 53 load balancer, availability zones, auto scaling groups, these two instances, like 4 instances, one cache tier, 2 databases, a region, a VPC. What's not visible in this diagram is a network, which is basically VPC, the routes, the firewalls, subnet rules, all these things. So there are several components that you need to create for this to work, right? Some are listed here in the left side. So in order to create all these, what will you do? You just log into your cloud account and you start spinning up all these services, is it? So, but when you have a team and your application is not so simple and it has several dependencies, it's not wise to create all these things manually. When a new employee joins, if you, let's say you created all these manually and some new fresher joins in, uh, you should look at that phase, because he will not understand what's happening, what's created. There is no document, nothing, right? So it's really hard to do knowledge transfers as well, right? So even for a small application, you probably need to make use of all the core services also. As I said before, you are basically using EC2 network, um, uh, security, all these things which we discussed before, right? Even for this simple application to deploy, you are basically using a lot of resources, and if you have to avoid the manual work, then how would you deploy all these things into the cloud? So that is basically why IAC was born. IAC is basically infrastructure as code. It not only deals with just cloud resources, it can be any infrastructure. So if you deploy any resources with code, then that can be considered IAC. Even Helm that deploys pods and services, all these things in Kubernetes cluster can be considered as an IAC tool. So IAC is basically a practice that treats infrastructures as code. It allows teams to manage and provision resources using configuration files instead of manual processes. What are the benefits of IAC? You basically do codification. Okay, this is benefits of IAC. You have automated deployments, which reduce time, right? So once you code your IAC, you can reuse that code and deploy the instances faster with some simple commands. So there is a improved consistency.
you can make sure that, see, if you deploy there are 4 servers here, right? EC2 servers. You might have mistakenly selected one configuration for this and other configuration for something else. So that might break your application, right? There is a possibility of human error. So there is no to maintain that consistency. IAC is very helpful because you are using the same code to deploy multiple servers or infrastructure. So there is reduced errors, which I said before. Human errors are reduced. It also promotes enhanced collaboration. Version control, it allows teams to collaborate on infrastructure changes effectively. There is increased agility. IAC enables faster development cycles. Basically, it's that, and cost savings as well. So, what does it mean converting your infrastructure as code, right? So it involves defining your infrastructure. I'll show you that. In the form of, you write the code in the form of JSON or YAML. Okay, you do the codification. First step is codification. Second step is automation, which is basically used to provision, configure, and manage infrastructure resources. IAC also promotes version control. When you have code, you obviously stored it in Git, right? Git provides version control. You can easily store the versions and roll back if anything breaks, right? We saw in the second session. So consistency, which was discussed already, and efficiency. So what are the popular tools that are used for cloud in the sense? If you had asked this question before, like 2-3 years back, there is only Terraform. Terraform was having a monopoly of cloud IAC. I mean, of course, AWS had its own IAC tool like CloudFormation, and GCP had deployment manager, right? But with those tools like CloudFormation, for example, you can only provision resources in the AWS cloud. You can't provision resources using CloudFormation in GCP cloud, right? So to be cloud agnostic, Terraform was the mostly used tool as IAC if you are using cloud resources. So Terraform is basically a tool developed by HashiCorp. They use some different language like HCL. It's called HashiCorp configuration language. Terraform enables you to manage your infrastructure like using code, which is basically IAC. What happens is, yeah, thank you. So in Terraform, there is something called state management. What it does is, whenever you write code and deploy resources into the cloud, Terraform creates a state of it. Whenever you make any changes to the code and try to redeploy, then it will compare the state with the existing cloud resources. State is basically the database, or it's telling you what's already running in the cloud, right? It compares these changes with the state, and it will tell you what it is creating, what it is adding or destroying, right? So that's how Terraform.state was an important core thing that allowed Terraform to work. There is a Terraform provider.tf. All the Terraform files used to end with .tf. So Terraform provider is where you provide which cloud service are you using, like is it AWS, GCP, or Azure, right? Terraform.tf_vars is a variables file where you pass different variables like the instance name or the IP addresses, whatever values you needed in the Terraform file. So I'll just show you like why Terraform is popular. Let me just stop sharing and reshare the screen. In Terraform, if you, let's say you wanted to spin up a EC2 instance, you can just go to Google and type this, right? There is a module available. If you go there, you can see the module already. So there is a large community that's developed over years, and community, they contribute to. They always when so I'll talk about open source, right? Then you will understand what contribution means. So basically, just understand that this is developed by community, and single EC2 instances. If you want to deploy a single EC2 instance, you can just copy this code and paste it in your Terraform code, and it will deploy it. So the instance type can be changed. It's a T2 micro here. Key name, monitoring, should it be true or false? What is the subnet ID in which this instance need to be deployed? These are the labels of that instance. And basically by mentioning this, you are using this particular module. Whenever Terraform encounters this code, it will go to this place and it will take this particular code, and it will pass these values to that module so that your instance get deployed. If you have multiple instances, you can just do a for each. It's like a for loop in our Python or some coding language. So 1, 2, 3 is there, right? Whenever this instance is this module is being processed, for each in the sense you are looping the entire code for every value mentioned in the for each. So each dot key in this is instance 1, instance 2, instance 3 will be the names of the 3 instances here. So this is again for spot instance. These are all normal instances like T2 micro, and this is a spot instance that is also of type T2 micro. Create spot instance is true. Spot instances in the sense are they are instances for which you bid a price for it. So this is a spot price you are giving. If your bid worked, then you will get an instance. So yeah, when I talked about provider here, provider.tf, I told that you need to mention which cloud provider you are working for. I mean you are using which cloud provider, or which cloud provider do you want to deploy these resources into. So you mention that here. You can create a separate file like provider.tf and mention the provider code there, or you can have a main.tf file where you can mention it as a block as well. Anything works here. So this is for EC2 instance. So what are the inputs you need to give? You can use in your code. All this is also mentioned clearly with divisions, right? There are different versions of this as well, where people develop new versions by fixing bugs, add new features. AWS also keeps updating their services, right? So based on that, the modules are also updated. In the Terraform registry, this is registry.terraform.io. You have several things, right? You have several providers as well. You can browse modules or providers. If you can see providers, these are the companies that provide modules for their own products, or you can go for which I'll just see. These are people who these are small providers. There are even users who develop modules and put it here. If you like that, you can use that as well. So let's say GCP. There are modules again. Kubernetes engine. If you want to create a Kubernetes cluster, then you can make use of this. So data, see, provider is Kubernetes. Okay, module is GKE. GKE is Kubernetes, Google Kubernetes engine. Okay, in which project inside GCP you need to use this. Okay, let me just tell you what a project is. So this is my Google Cloud account. So inside GCP, it works a bit different compared to AWS. You have something called projects, and in that projects you have folders. Okay, so I have only one thing. Everything comes under a single organization unit. So let's say your company is ABC. You will have a ABC thing here, and you can create multiple projects inside that ABC. let's say that ABC has several products like ABC Fitness, ABC, some shopping cart, shopping app, all that. So you can have a, fitness project and shopping project. So you are segregating your applications based on the project, and you can have multiple folders inside that, like login feature folder, something like that. It's possible to divide your application or company's products into different folders and use it. So each project has its own project ID, um, and yeah, you can spin up resources inside that. I don't have billing enabled. I didn't add my credit card, so I can't spin up resources. So that's why I just showing this homepage here. So yeah, the project ID is basically the project ID which I showed here. It's stately century something. So you just put it there. Name, the regions in which this Kubernetes cluster needs to spin up into, and there are several other options like how many worker nodes you need to have. Worker nodes in Google Kubernetes engine are all categorized as pool. You can have multiple pools. In each pool can be of different machine type. This is like T2 micro in AWS, right? So you can have E2 high, E2 low. You can have different types of worker nodes, right? So you can categorize different types into different pools. So this is one pool. If you want, you can just add another pool, just copy this and paste it here and create a different pool. You can have pool scopes, pool labels, all these things. Yeah, there are different commands in Terraform. Terraform init, plan, apply, and destroy. So whenever you create a new folder, you do it Terraform init. Let's say you created a Terraform, my Terraform code folder. You go inside that folder and execute Terraform init, and it will go through the provider's file. Where is it? So this provider file is there, right? It will first go through that provider's file, and it will get those plugins for you. And when you write the code and you want to test it first, instead of directly creating resources, you want to test it first to see what it is adding and what it is destroying. So Terraform plan is a command. So it will give you a clear summary of sorry. So it will create a clear summary of what resources it's creating, what resources it's modifying, and which resources it's deleting, right? So there is a clear color coding as well, with green, red, and red for destroy, green for creation, and yellow for modification. So once you are satisfied with the summary in the Terraform plan, you can just do Terraform apply, and this will actually create and manage, create, destroy, or modify resources in your cloud, right? And there is an option to Terraform destroy as well, to bring down all the cloud resources which you have created. So this is also helpful, because let's say you have created all these resources in your cloud, you are practicing, you put your credit card in that AWS cloud account, only then you are allowed to create resources, right? So once you are satisfied, you learned all the services, now you want to delete it. You don't remember which services you created. You created n number of them, right? Even if you miss one service, your credit card is it starts becoming empty. That's why if you create all these with the code, with one command, you are sure that everything is brought down. So that is also one of the advantages, right? So you know for sure that nothing is running your cloud which is created using the code. Yeah, so this is Terraform. In again, what happened in recent times, in the few weeks, months, in the recent months, is Terraform. It moved, HashiCorp moved Terraform from open source into a premium software, freemium to be specific. So they have started charging for it. So the open source community was furious. They were very angry, and they whatever Terraform code is there in the GitHub, they created a fork of it. They copied that code and they made modifications and developed their own open source software that does the exact same thing as Terraform, right? So let's look at them as well. So the first alternative to Terraform is Pulumni. So what it does is, just a second. So Pulumni helps us. Okay, so in Terraform, as I said, we are using HCL language. What is HCL? It's a HashiCorp configuration language. It's a different language, as you can see here. All this syntax, all these things are HashiCorp language. If you want to do a for loop, which we saw before, you are doing that for each, right? It's quite different from how we write in programming, right? So EC2, yeah, for each, yeah, this one. So you need to learn the syntax again to write any Terraform code. So yesterday in Prometheus query, we saw another language like PromQL, PQL, as I said. So every tool, if it comes up with new language, how many language should a person learn, right? Especially DevOps person, when they deal with so many tools, they can't keep learning multiple languages, right? So they have kept this in mind, and what they did, they made it code agnostic. You can use any code like Python, TypeScript, or Go. You learn one language and you can use this as well. So you spin up resources like cloud resources by writing code in normal coding language. You don't have to learn another coding language specially for this. So it has access to better tools. It's great for multi-cloud, but it can be a bit complex in case of smaller. Let's say you just want to spin up one EC2 instance. It can be a bit complex because you need to install and download all the Python code. Let's say, but it's a small con. It's not that much steeper learning curve, but it's the learning curve is there for any IAC code. That is also a small con. Basically, it helps you. I mean, Pulumni was developed with the idea that what if you code your cloud infrastructure using the programming language you already know, and yeah, it was a big hit again. So let's say if you want to consider or create 10 EC2 servers with slightly different names, you can just write a for loop in Python, right? So I'll show you the code how each tool differentiates the code by creating, looking at a code of S3 bucket. Okay, so there are advantages and disadvantages which are already discussed. And the other tool is Crossplane. Crossplane is an open source tool, and it helps manage our cloud infrastructure directly from within our Kubernetes cluster. Okay, so we often use Kubernetes to manage our applications, right? Another tool to manage our cloud resources. So like Terraform or something. So Crossplane, what it does is it brings these two worlds together. So the Crossplane was created from the idea of what if the workflow we know and love could be guaranteed to stay open source forever. It's basically hinting at Terraform. It was moved from open source to freemium, right? So this was aimed to stay open source forever. It's managed by a neutral foundation for the benefit of the community. So what we will do is here, there is a Kubernetes cluster which is already running, and you can manage your cloud resources from Kubernetes. Rather than Kubernetes inside cloud, it's Kubernetes becomes your admin panel. It's become your control plane for all your cloud resources, right? So cons is Kubernetes centric. Of course, you need to know what Kubernetes is and how to use Kubernetes before using this crossplane. That's the learning curve here. You have unified API, and you can use Kubernetes role-based access controls for access control of who creates what in cloud resources. And the next one is OpenTofu. This is the one which I talked before about. They forked the Terraform repository and created OpenTofu. They have renamed it to OpenTofu. So if you are used to using Terraform and HCL, OpenTofu is the best choice for us. Then it is truly open source, and it is designed for people who are already familiar with HCL, and at the same time want to use a open source tool. So let's look at, okay, there are pros and cons in this as well. This is a drop-in tool. What does it mean by drop-in tool is it's best for teams who are already using Terraform, and they can just switch to this. Okay, massive ecosystem. What does it mean? Terraform has developed a community over the years, right? And there are several modules already written there, uh, and all that community and modules which was already done and created is compatible with OpenTofu. So they can just use the same modules. You are just using OpenTofu instead of Terraform. Yeah. So these are the same code. Like if you want to create an S3 bucket, this is the same piece of code across different technologies or tools. Let's take a look at this. So Pulumi, how it is, right? You have a main.py. This is, as I said before, you can create cloud resources using Python, TypeScript, your own coding language. This is example is based on Python. So you have a main.py. You have a YAML file, that is the project configuration, like what kind of project, like AWS or GCP or which cloud you are using, and all that information. The infrastructure components test. This is the folder structure basically, and inside that you can write this code. So you are importing Pulumi as a module, right? You are importing Pulumi AWS. If for a GCP, it's Pulumi GCP, something like that. And you can just use the modules and write the Python code similarly to what is already there. There is a documentation as well. So you can just go to docs, Pulumi IAC, clouds, let's say Google Cloud. See, you can just go here and start your own, using these modules. So I can just go API docs. If you want to spin up a compute instance, you want to spin up a instance template, let's say. This is the code for it. You don't need to write also. You can just copy paste this and just change the values or pass it dynamically from your variables file, right? Each tool comes with a very clear documentation, and you can just use it. Of course, using documentation is not a bad thing. Even in some certification exams like Kubernetes certification exam, when you're asked to do things practically, you are allowed access to Kubernetes documentation to copy the YAML files and reuse them. So actually reading the documentation and understanding the product is also a very core skill for DevOps, because DevOps doesn't just deal with one technology to learn and by heart entire syntax of each particular of tool, right? It deals with multiple tools. Each tool is developed with its own flexibility in mind. You can't possibly remember every syntax, everything from multiple tools, right? So documentation, reading skills, and understanding that documentation is important. Yeah. And crossplane has its own crossplane folder structure, uh, and this is basically the code, and this is in the form of YAML, if you can see, because crossplane, as we saw before, you manage cloud resources from within a Kubernetes cluster. So Kubernetes deals with YAML files. So you write the cloud resources in the form of YAML, and you can spin them up. OpenTofu is basically a copy of Terraform. So you have everything with .tf only. And this is how you saw the EC2 instance also, right? In this document, you have a provider and all the other blocks. It's the same thing here. So you have a provider, you have a resource my bucket thing, okay, and bucket versioning, lifecycle. AWS S3 buckets have lifecycle rules and all, right? So you can configure all that here. So this is about IAC tools, especially which are used for cloud. And let's take a look at open source software. What open source is? We have been seeing all these open source softwares, right? Why is it a priority? Why is it mentioned everywhere? Okay, open source is nothing but it's a culture where uh, any person from any place in the world can come and work together with you, right? You create there is a problem, there is a pain point in the industry, and you want to resolve that using a software. You create a project for it, you put down your idea, and people with similar minds, they come together, they make a plan, they design the product and they code for it. So what do they get in return? You are developing a community, you become maintainer of the particular product. If that is resolving a pain point, then it will be obviously a hit. And people know that you are a maintainer, you are developing that. So you are bringing the community forward with by making it free and solving the pain points. See, even Kubernetes was developed by Google, okay, and they made it a open source software, which is why microservices became a bigger hit, right? And everybody starts using it, and the technology world as a whole is moving forward. So open source has a large impact on current technology advancement. And what I want to concentrate on is it's a CNCF. Okay, it's called Cloud Native Computing Foundation, and it has 216 open source projects. Let's take a look at all the projects. So in CNCF, it basically all the projects in CNCF are most of the projects are centered around Kubernetes and microservices. Microservices, as you know, they come with lot of challenges and complexity. To reduce that complexity and solve any disadvantages or pain points, a lot of projects have come up, and this is a community, open source community, that's managing these projects, right? You have several levels in the projects like graduated, incubating, sandbox, archived. Okay, any project that comes that is newly developed is under sandbox. Once they meet certain criteria, they can be promoted to incubating, and finally they can be promoted to graduated after further feature development and bug fixes and all that. If a project is abandoned, it will basically move into archived. So some of the graduated projects, as I said in the second session, GitOps, Argo CD is there, right? This is this runs as an agent in a, let's say, Kubernetes cluster, and it will pull changes from the Git repo and it makes changes in that cluster. So that is there. Container D, this is a runtime which we saw in the third session. Run C, Container D. These are container runtimes. Basically, they are used to run containers. Cryo is also one of the container runtime. These are graduated projects. That means these are very stable and they can be used in enterprise without any concerns. So Harbor is a container registry. Basically, you can store your images in Harbor, like how you store images in Docker Hub. So HCD, this is a not control plane component. This is a different tool altogether. Core DNS, we saw it when we deployed Kubernetes cluster yesterday. This is a Kubernetes DNS service. Okay, there are similar things. Fluentd for logging. We saw Prometheus, right? Prometheus for observability. It collects metrics. Fluentd is also used for monitoring only. I mean observability only. It deals with logging, application logs, and all that. So Helm, we used it to deploy Prometheus in Kubernetes, right? So Kubernetes, Helm, and Prometheus, all these are also in graduated projects only. And if you want to see what's happening inside, you can just go and you can find some videos, information about them. And if you want, there will be a GitHub link also here. And this is the Prometheus code basically. You can see how it works. This is Prometheus. I said right, time series database will be there. There is a Prometheus server component, node exporters, all these things. So all the architecture is defined here. Uh, and all the commands like how you can use it, everything is there. If you find any bug while using this particular Prometheus software, you can fork this code and you can fix it, test it, and once you make sure it's running, you can just raise a PR to this particular main repo like Prometheus. And there are like maintainers and contributors here. These people are all contributors. Like they have all made some significant changes in this Prometheus repo. So because of which the software is popular and it's working as it is right now. So there are still so many pull requests. If you are not capable of, you are not a coder, you are just a DevOps engineer, right? So in that case, when you find an issue, you can raise an issue here also. Someone will take up this issue and they can fix it and they will make this software better. So that's what a contribution is called. And all these are currently known issues. And if you are interested in coding, you can just take any of the issue, fix it, and raise a PR for it. So these are all the pending PRs. Someone has to, take it, approve it, and merge it into the main thing. If they feel like this is actually fixing that particular issue. So there are several things because this is open source. Nobody is getting paid for anything, and it's they also need to spend some extra time out of their daily life or daily work to actually see and contribute this stuff. So that's one of the code repos. Stack Overflow. Okay, whatever. Yeah, these are some of the graduated projects. These are incubating projects like Prometheus. Cortex is also there. Crossplane, which I just said. Here we have seen, right? Crossplane. That is here only, scheduling and orchestration. We have Artifact Hub, where we saw the yesterday we pulled in our Prometheus chat from here only, right? This particular Artifact Hub is also a incubating project in CNCF. So as you can see, all these software which you deal with in microservices, mostly they are part of CNCF. Even gRPC, this is a protocol through which microservices communicate with each other, right? So gRPC has revolutionized microservice API communication as well, with any communication between microservices, right? So this was also developed by Google and it is contributed to open source by Google. So several things are there for security, application deployment, storage, observability, and all this. Even open telemetry, it's becoming really popular. To this basically makes you see the traces of the application. Let's say you have a multiple services running within your cluster, okay, and you have open telemetry, then you can see like a graph visually how the request is coming into your cluster, how much time it's spending at each service, so that if some request is okay, if I clicked some button, it's taking so long to load the page. Some issues are there like that, right? Like performance issues. With tracing, you will see where that time is actually being spent, in which microservices it's being spent, and you can fix that bug so that latency can be reduced. So tracing has become a very important thing, and this is becoming really popular. There is a lot of demand for this. Demand for people who know how to use open telemetry and make things visible. If you want to get involved in open source, then you can go to any project, see their repo, and talk with the people who are maintaining and contributing to that, and you can start making changes. Both code and non-code. All these software, they need documentation also, right? So based on the documentation only, we know and use basically how to use this tool and all. Even all this is written by some people, and they don't code, right? They just write documentation in a clear manner that people can understand. So that is also a contribution. So this is how it is done. Yeah, I think that's it. Any questions you guys have? This is the last session. You can ask any questions from the previous session as well. So yeah, please speak up.
Yes, to all the participants, just if you have any doubts, you can talk with the resource person regarding DevOps, advancements, and everything. Any type of doubts, any doubts regarding it.
So also, I forgot to mention about certifications. Uh, if you see for any role, there is a lot of competition these days, and if you want to truly uh, make your profile stand out, you have several ways of doing it. One is certification, another is building your own profile. You can let me talk about certification first. So in AWS, you have several certifications like Solutions Certified Engineer or something like that. In GCP, you have Cloud ACE, which I already have, and there is a professional level certification as well. So it's a way to prove to companies that you are expert at this, and it will help you get your resume filtered out among all the others, right? So if you are interested in certification, go through the resources which are already there. You can reach out to me on LinkedIn also. I can help you or guide you how to complete a certification. But make sure that you really understand all the cloud resources. Not just there are several backdoor ways and illegal ways how you can get certification also, but it will only help you to get an interview call. But to clear the interview, you need to understand, especially when interviewers see your certification, they expect a lot from you, and they ask good type of questions only. So unless you don't understand the cloud, you can't get a job. So go through the cloud resources, get a certification after understanding all the services, then you can land a cloud support job or cloud architecture engineer, something like that. And the second way which I talked about is building your profile, right? So you can create your own cloud account. uh, of course it's not free, there will be some 300 credits starting. You have to, and they might expire in 1 month or some time limit is there. You practice it. So spend some time after creating the account before the credits expire, so that you don't spend your own money. uh, e- Even if you spend also, make sure that you destroy the resources after you learned and you are done playing around with them. uh, yeah, you can start navigating through these open source communities. You can start attending there is a community group. Let me just open that, discover on this services. This is a landscape which I wanted to show. Let me just open that, another one. Okay, all the softwares are categorized into this particular database. All these softwares are there, tools are there. CI/CD, all these tools are there. See, Jenkins is also there here. And yeah, if you want to navigate through all the tools based on the category, then this page is helpful. There are several communities like CNCF, Hyderabad, and all these things. Let me just open that. This is their page. For example, if you are in Hyderabad, they arrange these sessions, tech meetups every month in the last Saturday. You can attend them. You can, you know, there are several goals of attending these tech meetups. One is you get to know the people who are working in similar field. You build that network with other people. You will understand what's going on in the current technology in enterprise level, at enterprise level, right? So you can ask people how to for guidance, any career guidance, or how to understand a particular tool, any doubts which you don't understand by yourself. So there are such groups for every location, right? And there are several paid events which are major 2-day events, something like that. That's also happening. This time it's in Hyderabad. Every time it was happening in London, Europe, somewhere. First time it's happening in Hyderabad on 6th and 7th August.
there are several, where was that events? One second. Several sessions that are happening, right? So, Kubernetes for Gen AI, publishing the limits, how to use your pushing the limits. Sorry, Argo CD, how you can use it very effectively, and it's a 2 days event. There are so many sessions there. You can gain lot of knowledge. So keep an eye out for your for such events. If you have to spend some time, some amount also, they give student discounts also. So that is also there, right? If you are so good at all these tools, you can start giving sessions in these meetups. From audience, you can become a speaker, and when you put that in your LinkedIn profile or somewhere, then you are building your profile. Basically, you are showcasing your knowledge and zeal to share the knowledge to community for free or something like that. So all these things can help you get noticed by companies, and you can set yourself apart from all the rest of the people. So any questions?
Yeah, all the participants, please do respond if it is okay, or is any doubts you can ask. Students, kindly interact. Yeah, others. So any doubts regarding DevOps industry oriented or anything, you can ask actually. Still.
Yeah, not just the sessions. You can ask for any career advice if you want, or if you are stuck somewhere, you can ask that as well. If you obviously don't want to speak out in front of so many people, then you can connect with me on the LinkedIn also. It's there in the recordings as well. So yeah, I'm available to guide the people. No issues. Yeah, okay, ma'am. I think that's it for
Uh,
today.
yes, sir. Actually, thank you so much. 1 minute, sir. So I'll share the feedback link as well as the attendance link to you all. Already I have shared in Gmail. Okay. So everyone, please do respond for that. Definitely, everyone should fill that feedback form. Okay. The attendance as well as the feedback, the single form it is. So everyone, please kindly do fill it. So as every day that I'm sending the recording, this recording also will be sent soon. So students, any other doubts, any other questions, any other queries? So just do respond at least.
No,
Just
ma'am.
put thumbs up. Is it okay, everyone? Okay,
Yeah,
right.
another important quality in enterprise or in any company, you have to speak out. If you stay silent like this, people will think that you are not working and you are just a dull person, and they'll just put you in PIP or they do a layoff.
Yeah. The students are really not shy, but uh, they're really very much what is that? They're quite no, I don't know.
Yeah.
Yeah. Okay, so
Yeah.
shall we close it?
Yeah. Thank you, ma'am.
Okay, sir. So I'll say a few words and we'll close it actually. Okay, sir.
Thank you.
So, students, everyone, uh, on behalf of VIT AP University and School of Computer Science and Engineering, it is an honor to propose a vote of thanks to our esteemed resource person, Mr. Kedarnath Grande, Senior DevOps Engineer, TransUnion, Hyderabad, Telangana, India, for his valuable contribution to this 5-day workshop on DevOps 101, Build, Ship, and Scale Smarter, held between 15/7/2025 to 19/7/2025. I believe the knowledge and insight shared by our resource person will be instrumental in several topics like day one about DevOps, day two about Git fundamentals, C and CD, day three microservices, containerization, Docker, day four container orchestration, Kubernetes, and five today that is Google Cloud Platform Components, CNCF. So he handled all the sessions brilliant and very knowledgeable to be appreciated well. Thank you so much, sir. I also thanks the participants who participated all over the session. You maintained the decorum good, and that is also appreciable too. I need to remember that all the recordings have been shared to everyone, so you can talk to still in future. So today's recording will be sent soon. Okay. So now towards the closing words, myself, Dr. Suma, Associate Professor, Department of Artificial Intelligence and Machine Learning under the School of Computer Science and Engineering, VIT AP University, and Dr. Ishwarya Rayachoti, Professor, Department of Networking and Security under the School of Computer Science and Engineering, VIT University, who are the coordinators of this event, officially declare the 5-day hands-on workshop on DevOps 101, Build, Ship, and Scale Smarter is closed. So thank you all. Thank you all. Thank you, sir.
Yeah, thank you, ma'am.
Thank you, sir. Thank you. So everyone can leave now and fill the feedback form, that attendance form without fail. See your name, and then very carefully you have to fill this form. Okay. So you'll get the certificates within days. Within by 2-3 days, you will get the certificates. Okay. So thank you all the participants. Thank you.